We have a coin resting on a turntable a distance r from the axis of rotation. The turntable rotates with a constant speed of v. What's the minimum coefficient of static friction between the turntable and the coin? All right, so we can look at this two ways. We could look at it from the top down, and we can say, okay, so here's the coin, and it's traveling around the circle like this. But I think a better way to draw the free body diagram so we can look at the forces would be if we were to look at this coin as if it was coming toward us. So if it were coming toward us, here would be the coin. We would have its weight going down. We would have its normal force up or perpendicular to the surface it's resting on. And we would have the force of static friction pointing in the same direction of the acceleration, which is toward the center of the circle. So if we sum up the forces using Newton's second law in the radial direction, we would have the summation of forces equals ma. We know that centripetal acceleration is equal to v squared over r, so we have the summation of forces equals mv squared over r. All right, so what forces are we talking about when we're talking about the radial direction? Well, there's only one, and that's the force of static friction. So we have the force of static friction equals mv squared over r. Force of static friction equals mu s mg, and that's going to equal mv squared over r. We can divide both sides by mass and solve for mu s, and we would have mu s equals v squared over gr. And v squared over gr, that would be b.